Okay, so year 10, what we're going to be doing today is something completely new. We're going to be leaving that work on probability behind for now and having a look at some advanced trigonometry. Today, for our next few lessons, we're going to focus on the sine rule. Now, you will have done trigonometry before, so you'd have done that in year 9. I know we've done some revision of it this year since you've been off school, but you haven't come across the sine rule. Now, point number 1, the sine rule doesn't have to be used in right-angled triangles. So far, all the trigonometry you know, so SO, CA, TOA, is to do with right-angled triangles. The sine rule works on any triangle, even if it's not right-angled. But before we get to what the sine rule actually is, you need to know how to label the sides. And there's some really specific things you need to do. And if we don't get these specific things right at the very beginning, everything else is not going to work. So what you need to know is this: the vertices, or like the corners of the triangle, are labelled with capital letters. Normally would be A, B, and C, but doesn't have to be. Other point: the sides of a triangle are labelled with lowercase letters. So A, B, and C. Finally, the vertices and sides that are opposite each other have the same letter. Let me just show you what I mean by that. So here, this A matches up with this A. They are opposite each other. This B matches up with this B. They are opposite each other. And then finally, this C matches up with this C. They are opposite each other. Second example, so you may want to pause and have a go by yourself. This time I'm going to call them something different though. I'm going to say my angles are going to be called M, N, and O. Doesn't matter, the same rules apply. Capital letters at the vertices. So then we need to label lowercase m, lowercase n, lowercase o. So this is O here. So this is O here. This is N. So this is lowercase m. And then what colour? This is N. So this is lowercase n. With that in mind, have a go at task one on your sheet. Shouldn't take very long at all. Okay, so by now year 10, you should have practiced labelling the sides. And now I'm going to introduce you to what the sine rule actually says. So the sine rule is this, and what this means is, in any triangle at all, this is a true fact, that one side length divided by sine of the opposite angle is the same as the other side length divided by sine of the opposite angle is the same as the other side length divided by sine of the opposite angle. Vaguely complicated, should make a bit more sense once you've done an example. So, step 1, label up your sides. Doesn't really matter how. I am going to say angles are A, B, and C. And so therefore my matching sides are A, B, A, this is C, so this is C, B, like that. Now it looks like that. We are looking for a pair. So in this case, I know A and A. What do I not know? I don't know B or B, so I just ignore those. I know angle C, but I don't know sines, the side C. So I'm going to use A and C. So I'm going to write out A over sine A equals C over sine C. Now side A is 6, I'm just substituting, over sine 43 equals, now C we don't know, over sine 65. Now this is just an equation that needs solving. Now if we had like x over 6, we'd times by 6. So here we're timesing by sine 65. And so therefore into your calculator you're going to put sine 65 times by 6 over sine 43. And when you put it into your calculator, that is going to give you a value for side length C. Let's try that now. So sine 65 times fraction button 6 over sine 43. And that gives us this 7.97 centimetres to 2 decimal places. Second example then, just to help make a little bit more sense of that, this is quite difficult. We label up our angles and our sides. So I'm going to say A, B, C. So therefore we have A, B, and C. And we are looking for pairs, okay? So in this case, what do I know? Let's use a different colour pen to show you. I know sine C, because I've got C is 60. I don't know this C. I know angle B, but I don't know side B, although I want to find side B. And then I know side A, but not angle A. So this is the problem, because I don't have a pair yet. I don't have A and A, or B and B, or C and C. Luckily though, really simple way that I can find angle A, take a moment to think. Oh yes, we can find angle A by doing some lovely angles in a triangle. So we'll do 180 minus 73 minus 60, which is, should be able to do this quicker, 47 degrees. So therefore this is 47 degrees. And so now I know sine A. So then just thinking about it, we've got this pair here, we've got this pair A and A, and we want to find B. So the formula I'm going to write out is this. Then we substitute from the question into the formula. So side A is 7.5. Then sine, the angle is 47, equals B, which we don't know, over sine, and then the angle is 73. So after that, this looks really similar now to this line of working here. Here I times by sine 65. Here I'm going to times by sine 73. And so I put that into my calculator now. Sine 73, close bracket, times by fraction button, 7.5 over sine 47, close bracket, equals this. 9.81 centimetres to 2 decimal places. Okay. At this stage, year 10, if you're happy and confident, please just make a start with task 2. If you're not happy and confident, I'll do a couple more examples on the next slide to help you get started. Okay, so year 10, final example, just for now. As I say, if you're happy already, make sure you've got started. If you're less confident, watch this example, write it down, blah, 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 so on. So here we are being asked to work out the length marked y around your answer to the nearest 0.1 centimetre. Fine. So to begin with, we need to label our sides. So this is angle A, so this is side A. Oh, there's my pen not working. This is angle B, so this is side B. This is angle C, so this is side C. And remember, we label our sides with lowercase letters. Now after that, I would begin thinking about which pair I had. So in this case, I don't have A or A. I have B and B. C I want to find out, and I have angle C. So this is fun. So I'm going to write out now B over sine B equals C over sine C. Now B from the diagram is 8.3 over sine 75 equals C. Now C, I could either call it C or I could call it Y here. It doesn't make too much difference. So I'm going to go for Y over sine 58. So now we've got y divided by sine 58. So to find y, we multiply both sides by sine 58. And so into your calculator in just one step, you can type in sine 58, it's meant to be a 5 there, times by fraction button 8.3 over sine 75. Let me just try that now. Sine 58 times by fraction button 8.3 sine 75, and that gives me, and I'm just going to write out the unrounded answer, 7.28 7101148. The question asks my answer rounded to the nearest 0.1 centimetre. So that means I'm going to chop off my number here. Because this is an 8, we round up. And so my final answer is 7.3 centimetres. With that in mind, year 10, have a go at task 2 on your sheet. As ever, let me know how you get on. If anything's not quite working out, just drop me an email or message me and show my homework, and I can try and support you a bit more with this.